Hi guys, it's been a long time that I see you guys. I really miss you guys so much. And from today, we're gonna start some new materials in geometry, and we're gonna start the chapter 12, which is basic probability and statistic. And today in this video, we're gonna introduce you to 12.1 representing a sample space. So if this is your first time watching the video, please remind yourself I have everything upload on Google Classroom. So if you want to pull up the worksheet while you're watching my video, please do so. And you are welcome to get a piece of paper or get your notebook and take some notes. All right, here we're gonna start. So, all right, okay. So I'm sharing my screen with you, and today we're gonna talk about represent sample space. First of all, I want to give you a definition of sample space. The sample space of an experiment is a set. All right, let me put a highlighter here. It's a set of all possible outcomes. Okay, and the sample space can be found using organized list, organized list, table, or tree diagram. Great. Okay. Basically, we are trying to find all the possible outcomes, and we're gonna make a we can find it use a list, a table, or tree diagram. Let's look at example number 1. I want you to represent the sample space for the experiment below by making an organized list, a table, and a tree diagram. So here's the situation. Mike's babysitter can drink either apple juice or milk from a bottle or a toddler cup. So over here we have two options, apple juice or milk, and it's from a bottle or toddler cup. So if you think about the combination, Mikey's baby can drink, if we want to make a list, okay, his baby can drink apple juice, okay, and from a bottle, okay. He can also drink apple juice from a toddler cup. He can drink milk from a bottle. And the last option he can drink milk from a toddler cup. Okay, so he has his baby have 4 options, 4 combinations. So everything I list over here is called our sample space. Okay, so this is our first method, list. And the second method, we can represent it, we can use a table. Okay, so when we use a table, if you only have 2 possible options they can choose from, you can use a two-way table. So let me find the table. All right, where's the table? Okay, all right. So the first, for the row, we can simply write it down what kind of, what method he drink from. So we can do bottle, and over here toddler cup. Okay, and and for each row we can use what he drink, what kind of drink the baby drink, apple juice or milk. Okay, so over here is an outcome. Okay, if we only use initials to represent what the combinations are, apple juice and bottle, we can use A represent apple juice, B represent bottle. Okay, so let me be more clear. B is the bottle, C is the cup, A, we can use apple juice. M, we can use milk. So over here, using bottle to drink milk will be milk, bottle. And over here, apple juice and toddler cup, milk, and toddler cup. Okay, so there's another way to find your all the possible outcome. Okay, so you can see in the table what we find is exactly match the list. All right, so let me show you the last way we can use a tree diagram. Tree diagram, according to the name, you can imagine it looks like a tree. Okay, the last time we talked about something tree is when we do the prime factor, right? All right, so for the tree diagram, it's a little bit harder for me to write on the Word document. So let me put myself back on here. So we're gonna use this board to give you a tree diagram. So if you can, if you remember the question, so first of all, like the baby gonna pick a drink, right? So all the outcome we have over here, and let's make our baby pick a drink. Okay, so baby can pick two kinds of drink. It can be apple juice. It can be milk. Okay, all right. So after they pick a drink, then they have to pick the method they receive the drink. So apple juice, we can use bottle. We can use toddler cup. And for milk, and it's the same thing. Bottle and toddler cup. Okay, so for each of them, we have one possible outcome. Over here, you have apple juice and bottle, AB. Over here, apple juice, toddler cup, AC. Over here, you have milk, bottle, MB, milk, toddler cup, MC. All right, so we have total 4 possible outcomes. And if I ask you, okay, what's this possible outcome means? You're gonna say this is the outcome that a baby drink milk out of a bottle. Okay, so if I ask you, okay, how many outcomes the baby drink out of a bottle? So you need to find over here, bottle 1 and another bottle 2. If I ask you how many outcomes that a baby drink apple juice, you will say, okay, apple juice, I have 2 outcomes, 1, 2. All right, so this is about the sample space and outcome. All right, so this is the first concept we learned today, sample space and outcome. And there are about 4 questions on Alex you can work on. All right, let's go back to my screen. Okay, second of all, we want to talk about fundamental counting principle. So what is fundamental counting principle? Fundamental counting principle is saying the number of all possible outcomes. All right, again, let me highlight this. The number of all possible outcomes for an experiment can be found by multiplying the number of possible outcomes from each stage or event. Okay, there's, all right. I'm so appreciate the test correction stuff. All right, so this is also calling the multiplication rule in the statistic. And then what's what is happening over here is saying that number of all possible outcome of experience can be found by multiplying the number of possible outcome for each stage or event. For example, if we go back here, so if we look at Mikey's baby's sister question again. So over here we have two different events. Number one is drink apple juice or milk. Okay. And event number two, they're gonna drink it from bottle or toddler cup. Okay. So in this event, they have possibly two outcomes. Okay. And in this event, you also have possibly two outcomes. So over here, they said all the sample space or all the possible outcomes is this 2 multiply this 2. Okay, 2 times 2 equals to 4 outcomes. So to conform the fundamental counting principles, right? You can see over here I have 1, 2, 3, 4 outcomes, and also on the table tree diagram also confirms that we have total 4 outcome come from the 2 possible ways they drink times the two possible drinks they will get times 2 possible ways they drink. Okay, all right, this is a fundamental counting principle, and how to use that is very simple. You just take each event's outcome and multiply them together. So for example 2, find all possible outcomes for the following examples. All right, so in this example, they display it with a table. So over here we have 1, 2, 3, 4, 5, 6 events, and each event they have a possible outcomes. So how to get the overall possible outcomes in the sample space, how many outcome in the sample space, you need to just simply multiply them together. 8 times 6 times 8 times 5 times 3 times 5. All right, that will be equals to whatever it is. Okay, let me find the calculator. All right, do not have a calculator. Awesome. All right, let's do this. And also, maybe I should not do that. Let's use decimals. Okay. All right, that's what we use in class, right? You're gonna stick to it and you're gonna get very familiar with it. Just copy paste it. Okay, so 28800. All right, the good reason for why we're using this principle, because a lot of times, there are a lot of outcome in the sample space. For the Mikey's problem, we can just list it out and count there are 4 outcomes. But for the outcome, for the example over here, they have like almost 29,000 outcomes. There's no possible you can just list all of them out. Okay, so that is why we use the fundamental counting principle, and this is very, very important in probability. All right, let's look at another example. In this example, they don't have a table for you, and but they do have a list. Let's read it very quick. The drama club held tryouts for 6 roles in a 1-act play. 5 people auditioned for the leading female. Okay, let's make the list out. So lead female, and 3 of them for lead male, 8 of them for best friend, 4 of them for mom, 2 of them for dad, and 3 of them for crazy aunt. That's my favorite role in the show. And okay, all right, favorite aunt. So there are 1, 2, 3, 4, 5, 6 events, and each event have a different possible outcomes. So if you want to find the combination of all the casting, so what you need to do, just multiply them together according to the fundamental counting principle, and 5 times 3 times 8 times 4 times 2 times 3. All right, so again, copy and paste it in decimals. Okay, you can see how lazy I am. 2880. Okay, so here is your answer. They have 2,880 possible outcomes. All right, so give you a summary of today. Let me pull myself up. You know what? Let's just use that. So today we learned what is outcome, what is sample space, which is a set of possible outcome, and we know how to find our sample space, how to display it. You can use a list, you can use a table, you can also use a tree diagram. And then we learn the multiplication rule, which is a fundamental mental counting principle. You just find all the events and multiply their possible outcome together to get the possible outcome for the entire event. Okay, so that's and another word I want to like mention over here, multiplication rule working only when the question with have and. So for example over here, so you eventually each outcome you will have pen color of red and comfort set of blah blah, sheet set and blah blah blah. Okay, the relationship between each event is and. All right, so okay, let me pull myself back. All right, so I hope you learned something from this lesson, and I will be online again another time tomorrow or the day after tomorrow to introduce 12.2. And please follow the ALEKS due date to complete your ALEKS assignment. And we're all in this together. Again, me and all the teachers, I miss you guys so much. I hope you still can learn and be the best of yourself. All right, I will see you next time, and bye bye.